Section 5.5, Standard Form. Standard form of a linear equation. The standard form of a linear equation is ax plus by equals c, where a, b, and c are integers. Okay, and so what this means is that your a, b, and c values cannot be fractions or decimals. All right, so a, b, and c cannot be fractions or decimals. And so our standard form equation is ax plus by equals c. So a and b are your non-fraction, non-decimal numbers, as well as c, and x and y are on the same side of the equation. So in the first example, it asks us to rewrite the equation in standard form using integers. So that means we want to get x and y on the same side. So for the first one, we have to subtract 2y from both sides to get x and y on the same side. So we end up with x minus 2y equals negative 4. Since there are no decimals or fractions present, this is our standard form. In the second equation, same thing. We want to try to get x and y on the same side. In order to do that, we have to add 3/7 x to both sides. And so this gives us 3/7 x plus y equals 5. This time we have a fraction. It's 3/7. And the only way to remove this fraction would be to multiply everything by the denominator. So in this case, we're multiplying everything by 7. Here, 3/7 times 7 is just 3. So 3x, and then 7 times y is 7y, and then 7 times 5 is 35. So this is our equation in standard form. All right, same thing in example 3. We want to write this in standard form. In order to write it in standard form, we first have to distribute the negative 2. So we have negative 2x plus 6 equals y plus 3. Then we want to subtract 3 from both sides, and we get y equals negative 2x plus 3. The last thing we need to do is get the x and y on the same side. So we're going to add 2x to both sides to move the x value, and we get 2x plus y equals 3 is our standard form equation. The y-intercept is the coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always 0. The x-intercept, on the other hand, is the x-coordinate of the point where the graph intersects the x-axis. The y-coordinate of this point is always 0. So when graphing standard form, it's easiest to graph it when using your intercepts. So we're going to talk about how to find the x and y intercepts of a standard form equation. So in this first example, we have 5x minus 2y equals 10, and they want us to find the x and y intercepts. So let's start by finding the x-intercept. To find the x-intercept, you start by replacing the y value with 0 and solving for x. So we've got 5x minus 2 times 0 equals 10. 2 times 0 is just 0, so we've got 5x equals 10. We're going to divide by 5, and we get x to equal 2. So our x-intercept is 2, or we could say the point 2, 0. Then to find our y-intercept, we'll do the same thing, but this time we'll plug 0 in for x. So we've got 5 times 0 minus 2y equals 10. 5 times 0 is 0, so you've got negative 2y equals 10. We'll divide by negative 2, and you get y to equal negative 5. So our y-intercept is negative 5, or we could say the point 0, negative 5. We're going to do the same thing in this problem. We want to find our x and y intercept, so we plug in 0 for the other variable and solve for the one we're looking for. So in this case, let's start with the x-intercept again. So to solve for the x-intercept, you plug in 0 for y. So we've got negative 3x plus 5 times 0 equals 30. 5 times 0 is 0, so you've got negative 3x equals 30. We're going to divide by negative 3, and we get x equals negative 10. So our x-intercept is negative 10, or we could say negative 10, 0. Then we're going to find the y-intercept. So we're going to plug in 0 for x. So we got negative 3 times 0 plus 5y equals 30. Negative 3 times 0 is 0. So we've got 5y equals 30. We'll divide by 5 on both sides. And we get y to equal 6 in this case. So our y-intercept is 6. Or we could say the point 0, 6. Now we're going to talk about graphing horizontal and vertical lines. Anytime you have an equation where it's x equals some number, this is representative of a vertical line at that number. On the other hand, y equals just the number is a horizontal line at that number. So in this first example, we have x equals negative 3. So if we go to negative 3 on the x-axis, we can put a point here. But what we need to remember is x equals a number is a vertical line at that number. So we have a vertical line defined for all values of x equals negative 3. So this is our vertical line equation, or vertical line graph. In the second example, we've got y equals 4. So we put our dot at the 4 on the y-axis, and then we remember that y equals a number is a horizontal line at that value. So in this case, it's a horizontal line at y equals 4. A media download store is selling songs for $1 a piece and movies for $12 each. You have a total of $60. Write an equation that describes the items you can buy. So in this case, let's let x equal songs and y equal movies. So if we're setting up our equation here, we have to remember that each song is $1. So that's 1x, because we don't know how many songs they bought, plus let's let movies be y, so $12 per movie, so 12y equals our total of 60. So this is our standard form equation that represents the situation. If we were to graph this, we could do so using our x and y intercepts. So in this case, if I look at it carefully, I know that my x-intercept would just be 60. So that means my graph would be defined at the point 60, 0. And then my y-intercept, on the other hand, would be 60 divided by 12, so my y-intercept would be 5, or the point 0, 5. And if I wanted to graph this, I could graph this. You can create a table of values and a graph to determine all of the possible solutions that you could have. And so this graph here represents some of those possible solutions. So in this case, we know that you have the opportunity to buy 60 songs and 0 movies, or you could buy 0 songs and 5 movies, or you could buy the combination of possibly 3 movies and 24 songs and still keep your amount at $60.